Hello everyone, welcome to Math Q&A. In this video, we're going to be deriving the sum equation of the sequence we've been talking about and which we've been using as an example in the previous videos, which is 2, 4, 8, 16, 32, all the way up. Let's write our sequence down. Oh, it's 2, 4, 8, 16. This is a geometric series. Now, sorry, this is a geometric sequence, by the way. So now we are talking about series in this video. So we have to change this thing into a plus because now this is no longer a sequence, but a series. Okay. Now, how do you know it's a geometric series? It's because we are actually applying this on a geometric sequence. We have also defined in the video so many times that a geometric sequence has the same value when you divide the next value by the previous value. So like for instance, 4 divided by 2 is 2 and 8 divided by 4 is 2. 16 divided by 8 is 2 as well, all the way to infinity. Okay. Now let's go and use the equation we've derived previously to actually find now the equation of this geometric series. Now, so we know that Sn is equal to a 1 minus r exponent n divided by 1 minus r. And you said where r is not equal to 1. Okay, now let's go substitute our values in there. Now a is the first term, so a is equal to 2 multiplied by 1 minus r is this 2. I said in the previous video it's called a ratio, and that is actually 2 divided by 1 minus 2. Now let's go further. Well, if we sort this out, we realize 1 minus 2 is actually minus 1. The denominator, 1 minus 2 is minus 1. And then if we multiply the top by the bottom, we're going to get minus 2, 1 minus 2 exponent n. If you multiply this by that, you get minus 2 plus 2 times 2 exponent n. Okay. Now, let's apply this equation. Well, this equation can be further written as 2 multiplied by 2 exponent n minus 2, just to make it more prettier. Okay. Now, since we know, if you look at this, you can clearly see that, well, the first term here is 2. The second term is, well, the first term is 2, the second term is 4, the third term is 8. Now, the fourth term is 16. I said that this Sn means that let's sum the first values of this series from the first value to the specific value which we're specifying here. So let's say now we actually want to sum the first 2 values of the sequence, or the first 3 values of the sequence, which in this instance we know that it's actually 2 plus 4, which is actually 6 plus 8, which is 14. Okay. Now let's go and prove this. 8 plus 6 is 14, of course, yes. Now let's say, okay, find S. Now we say we want to sum this up to 3. So the sum of the first 3 terms. So S3 is going to be equal to 2 multiplied by 2, 3 minus 2. And then it's going to be 2. 2 exponent 3 is 8 minus 2. 8 times 2 is 16 minus 2, which is 14. And that is correct. Now further on, let's go and actually do this also for, let's say maybe the 5th or the 6th or the 7th. Let's say S7. That is going to be equal to 2 multiplied by 2 exponent 7 minus 2, which is going to be 2. 2 exponent 7 is 128. Minus 2. 128 times 2 is 256. Minus 2. 256 minus 2 is 254. Okay. So this is how we use this equation. So if you want to sum the values of a geometric series, we use this equation. And please note that it's called a finite geometric series because a geometric series is not like an arithmetic series. A geometric series has more properties where sometimes it can converge to 0, so meaning that it can be finite as n goes to infinity. Okay, I'll explain that in the next video, so stay tuned. Thank you.